Alright guys, let's see how we can solve another question from the second chapter of the Meriam textbook, Engineering Mechanics. And in this one, we have a portion of a mechanical coin sorter that works as follows. So pennies and dimes roll down the 20 degrees incline. The last triangular portion of this sorter kind of pivots the horizontal axis about O. So because the dimes are lighter, the triangular portion remains stationary, so it can roll into the right collection column. And pennies, because they are a little bit heavier, we have the mass of each of them, it's going to pivot the triangular portion or clockwise, so they can roll into the left collection column. So the question is asking to determine the moment of this penny that we can see about point O in terms of the slant distance S in millimeters. So we can see the S in the figure. So very similar to what we discussed in the previous videos regarding the 2D moment. The only force that we have in here is the weight of this coin or the penny, which we can show it like this. We're going to call it W because we have the mass, and for finding the weight we need to multiply mass and acceleration of gravity on Earth. So the mass, as we can see, is 3.06 grams. So 3.06. We're gonna divide it by 1,000 in order to get it in kilogram. And we know our G is 9.81 meter per square second. So if we multiply this by 9.81, this is gonna give us the mass in newtons. So this will be newtons. So I'm just gonna draw this part in here, then we can see it better. So we have this point O and we have the mass in here, which is W. And since we're going to use our 2D shortcut, we're going to break this down into two different components. One, so if we call our axis like this, we can call our Y and our X. And also we know that this angle is 20 degrees. So if that angle is 20 degrees, I'm trying to resolve this force into two components, one parallel to Y and one parallel to X. And the reason I'm doing this is that finding the distances would be much easier if we go with this, and this will be the center of the coin. So let's find the moment. So we are trying to figure out the moment about point O counterclockwise, positive as always. And for that, we have also this angle would be 20 degrees too, because of the same trick that we discussed over and over in the channel when we have two angles that each side is perpendicular to the other one. These two are the same, and those two angles in here, we have these two and these two. So this is perpendicular to this. This will be to this one. So these two are the same. All right, so let's start with the moment of the Y component, which is this one. So as we can see, the moment is going to be in this direction. So it's clockwise. We're going to have negative. And for finding the components of the force, we know that the X component would be W sine of 20 degrees, and the other one would be W cosine of 20 degrees. All right, so we have W cosine of 20 degrees, and the distance that we are interested is the vertical distance to the line of action, which is this distance. And from the question, we know that would be S. So times S, that's the moment of the Y component. And for X component, also we have the same thing. The moment is going to be in this direction, clockwise. Another negative moment. The force is W sine of 20 degrees. And the distance would be the vertical distance to the line of action. This is the line of action. And this will be our vertical distance. So we are looking for this. So in the question, we have this little distance, 3.5 millimeter. And let me draw our coin to the scale. And this will be our coin. So we know this distance is 3.5, and this would be the radius of this coin, which would be what we have from here to here. We know that one is 9.5 millimeter. So basically we have 9.5 plus 3.5. And since the question is saying that the distance is in millimeter, at the end of this, we're going to get our moment in Newton millimeter. All right, let's find the first part. So we have the weight, which was 3.06 times 9.81 divided by 1000. That's going to be our weight, 20. So it's going to be 0.028 s. We have a negative sign here too. And in the second one, we're going to multiply that by sine of 20. And also we have 9.5 plus 13.5, which is going to be 13. And this is going to give us minus 0.1335. And since we have a negative sign, that shows that our moment is clockwise. So yeah, that would be everything for this one. Hope everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.